We're going to look at conditional probability just as a summary and look at some key questions that have been asked. So let's have a look at the conditional probability formula. So this is the probability of A occurring given that B has occurred, and that is equal to the probability of A intersect B, or the probability of A and B, divided by the probability of B. Now, let's think about what this is saying. So we've got a proper understanding. So let's change to a thicker, there we go, that'll do. Let's change to orange. So the probability that B has occurred. So that means we're looking just at the B circle. Okay, so given that B has occurred, okay, given that B has occurred, what is the probability of A occurring? Okay, well, the A part is the overlap, isn't it? So this is the overlap because this is where the parts of A are contained. Okay, we know that there are bits of A in this. So given that B has occurred, which means you're just looking at the B circle, what's the probability that A has occurred? That means you're looking at the intersection of A and B because we know that that intersection is part of A. So that's what the formula means. Okay. Now, the other thing you've got to be aware of is independent events. Now, we have previously established that the probability of A given B is equal to the probability of A if the events are independent. Okay. And the probability of B given A is equal to the probability of B, again, if the events are independent. And we also have the probability of A and B occurring is the probability of A times the probability of B. Okay, so we've already proved that. Now, there's an important thing we must be aware of. Independent events are not mutually exclusive events. Okay, so let's remind ourselves what independent events are and what mutually exclusive events are, because you'll be drawing some pictures to answer some of the questions. So it's important that you understand the difference between these two. So if the probability of occurrence of an event A is not affected by the occurrence of another event B, then A and B are said to be independent events. Okay, so here's a Venn diagram showing, we could draw a Venn diagram like this for independent events where there's overlap. Okay, it doesn't mean that A and B, if A and B are independent, it doesn't mean they are separated on the Venn diagram. Okay, so now let's have a look at mutually exclusive events. Now, mutually exclusive events are two events that can't occur at the same time. All right, now that means your Venn diagram has to look like this. There are two separate circles, there is no overlap. Also, obviously that means the probability of the intersection is 0. So just be aware, independent events are not mutually exclusive events, okay? Now, let's have a look at this example question 3. The probability question from the practice questions. Now, this comes from a Victorian paper, and it's probably pushing the boundaries a little bit of what we did at school, but we can still work it out using the theory we just looked at above. And we're going to do that by drawing a picture and using the formula. Now, it says A and B are events of a sample space S, and we're given the probability of A and B occurring, and also the probability of A and not B occurring. So this little dash means not B. It's a complement of B. And we're going to work out the probability of not B given A has occurred. So first things first is let's get some sense of what's happening with this question. We need to work out this little formula we're going to write down. So probability of not B given A, right, according to our formula that we wrote above for conditional probability, it's the probability of not B and A, or intersect A, and divided by the probability of A. Now, just so we're consistent with the way this is written down, we could also write this down as probability of A intersect not B divided by the probability of A. Now, the reason I did that is because then it matches up perfectly with what we're given here. So we already have half of the question done. Okay, we have this part here, the numerator, that is 3/7, isn't it? So we already got that part done. So the probability of A intersect not B is 3/7. So we just have to work out what the probability of A is. Now, to do that, we have to have an understanding of what A intersect not B is. So we're just going to draw a Venn diagram here as our next step. So draw the rectangle. And let's do some overlapping circles. Okay, let's call this A and this B. Okay, so let's have a look at what A and not B means. All right, well, not B, so let's use a different color for this. Not B is everything outside of the circle B. So that means I'm going to just color in everything outside of B. Okay, everything outside of B, I'm shading that in. Okay, so not B has been shaded in with the orange. Now let's change colors and we'll look at the, what about A? Let's shade in A now because we've got A intersect not B, so let's shade in A. So A is obviously everything inside the A circle. So it's everything. Here we go. Maybe I should use a different color here because it's a bit similar, so let's use black. Okay, so everything inside the A circle is A. Now, the overlap with the orange lines, which is not B, and the black lines, which is A, the overlap is A intersect not B. Okay, so let me just hover around that right area. Here we go. So the overlap is this section here. Okay, so let me just draw a little arrow of that. So that area in here, that overlap, so all this green part in here, right, that is A intersect not B. Okay, so now we know what that space is. Let's redraw a diagram so it's a little bit neater. Not so much lines there. So let's see if I can copy and paste that. Edit, copy, edit, paste. Yeah, that works. There we go. Let's copy and paste. Okay, so grab that. There it is. That's B. And I don't think we can do the same. Oh, we will try. Edit, copy, edit, paste. No, not quite. Didn't work. All right. Let's just copy and paste this then. Edit, copy, edit, paste. All right. So let's move that over here. All right. So we've got A and B. And let's label those. All right. So here's A. Here's B. Now, we know that the middle part here, that little bit in there, we know that is A intersect B. And this part in here is A intersect not B. All right. Now, that's important because now we can work out what A is, can't we? So if I said to you, tell me what A is, well, A is the A intersect not B plus the A intersect B, isn't it? So that means the probability of A is equal to the probability of A intersect not B plus the probability of A intersect B. Okay, so now we already know what A intersect not B is, because if we go back to our question here, A intersect not B is 3/7 and A intersect B is 2/5. So we've got 3/7 plus 2/5. Yeah. Which means we can go back to our question over here, right? And we can work out our answer, can't we? Because we have A intersect not B is 3/7, that's given to us. And then probability of A is 3/7 plus 2/5. So we have 3/7 plus 2/5. And that should simplify to 15 on 29. Put that into your calculator, should get 15 on 29. Okay, so that's question 3 done. All right, so I started here, I drew the picture. So you're looking at this for progression here. I've gone from there, then I went to there, okay. Then I went to here, and then I've gone back to the top. In a circle, if you like, I've gone back to here. Okay, so, all right, so get that down and let's have a look at question 4. Okay, so question 4. All right, now we're going to draw a Venn diagram for this as well. And let's start with that. And that way we've got something to put the numbers on. Okay, let's call that A. Actually, I need to have a bit more overlap than that. There we go. All right, so we've got A and we've got B. So let's label those. So A and B. All right, now let's choose orange here. Okay, now it tells me that the probability of A and B, which is the intersection, is P. So I'm going to just put down P here. All right. Now, the next thing it tells me is the probability of B and not A. Now, B and not A, if we follow on from the previous question, B and not A will be here. Okay, so this little region here, B or not A. So let me just tag that. That part there is not A intersect B. All right, so just this little section here. Now that is P minus 1/8. Yep. So P minus 1/8. All right. Now A intersect not B. So A and not B is that's this little section in here. So let me tag that. That part there is A intersect not B. All right, so that will be 3p on 5, the probability. Okay, so we've got those tagged. Now for independent events, what do we know? Because it tells us, so we've tagged all the information. Now it tells us that they're independent events. Now that means, so I'm going to write that down. So independent events. Right. Now that means that probability of A and B, which is the intersection, the probability of A and B, A intersect B, is the probability of A multiplied by the probability of B. Okay, so we know that, and now we can work out the answer. Because we know that the intersection of the probability is P, so I'm just going to do a substitution here. So this will be P. Now, the probability of A is the entire circle of A. So that means the 3p on 5 and the p. So let's add those together. So 3p on 5 plus the p, right, multiplied by, now b will be the entire B circle. So that's p plus p minus 1/8. Okay, so let's solve that equation. Now, what do we have? We've got p is equal to, now if you simplify this, p is just 5p on 5, so you're going to get 8p on 5 for that part there. And then brackets, this will be 2p minus 1/8. Okay, now let's put everything over one denominator, and you're going to have p is equal to 8p on 5 brackets, and then we're going to have 16p minus 1 on 8. Okay, now that's going to give us p is equal to, now we're going to have 5/8 of 40, and then for the numerator we're just going to expand those brackets there, and you are going to get 128p squared minus 8p. Okay, now we're going to multiply everything by 40, so you're going to get 40p is equal to 128 p squared minus 8p. Okay, so that's going to give us 128 p squared minus 48p is equal to 0. If we divide through by 16, that should simplify to 8p squared minus 3p equal to 0. And then obviously we'll take out a common factor. P outside of 8p minus 3 is equal to 0. So you're going to get p is equal to 0, or p is equal to 3/8. So now we know that the we're not going to have p equals 0 there, but we are going to have p is equal to 3/8. So that is our solution. Okay, so that will be option number C. Okay, option number C. So you can see there that the Venn diagram is the key for that question. Okay, very important part of the question is so you can tag all the information. All right, so you can see without the diagram, this is going to be a whole lot of information which is not going to make sense. So Now, obviously, you've got to choose C because P is not equal to 0. Okay? P not equal to 0. That would mean there'd be mutually exclusive events there. So we have the answer for C. Now let's have a look at the next question. So make sure all that's written down. Question 5 is next. Now for question 5, we're going to draw a picture again. This time it does say they're mutually exclusive events, so I would be tempted to straight away just get an idea of what's happening. There's A, and there's B. Okay. Now, it tells me that the probability of A occurring is P. So I'll put P here. The probability of A occurring is P and B is Q. Okay, so put a Q there. Now, we know that for probability, the sum of all the probabilities have to be 1. Okay, so that means the outside of it, A and B, outside of A and B, it must be 1 minus P, so P there, minus Q. Okay, because when I add up all the probabilities in this Venn diagram, I should get 1. P plus Q plus 1 minus P minus Q should be 1. Okay, so now, not A and not B is all this space outside, isn't it? It's all the space outside of the circle. So not A and not B is everything outside of the circles. Okay, now, so the probability of not A and not B, right? Well, that's going to be 1 minus P minus Q. And we can factorize that and write that as 1 minus P plus Q, which then works out to be C. Okay, so drawing the picture is key. Got to do the Venn diagram and tag the correct information in the Venn diagram. All right, last question. This one here, question 6. I'm going to draw a Venn diagram again. Right, we'll have some overlapping circles. Here we go. There we go. This is A. This is B. And it tells me that I'm working with the probability of A given B. So that means the probability of A intersect B divided by the probability of B. Okay, so that's the formula I'm working with. They give you what A given B is, so I can just write down P, this part here, and then I'm going to have probability of A intersect B divided by the probability of B. B is just P squared. Okay, so then I can work out that the probability, so therefore the probability of A intersect B is P cubed. Now, the question asked me to find the probability of B given A. Okay, so I'm going to write the formula down for that. Right, the probability of B given A right, is the probability of B and A, or B intersect A, divided by the probability of A. Okay, now we know what B intersect A is. It's P cubed, isn't it? So P cubed there. And in the question, they tell us that The probability of A is a third. Okay, sorry, P to the third. So P to the third. And then using your index laws, that's just going to be P to the 2 2/3, which is 8/3. So that is D, that last one there. Okay, so that's it.